Problem 1-121. For each pair of equations below, determine where the graphs intersect. So right now we have two different functions here. This is a system of equations, and we're trying to figure out where do the graphs cross. With this one, we have two lines. And if we're trying to do this without the graphing calculator, we want to think about when I take an input and I put it in here, it's got to have the same output as this function here. So whatever I put in for x, if I put in for each of these, we would get the same answer out. So in other words, the y's have to equal each other. And if the y's equal each other, we know that these two expressions have to equal each other. So we can take it here and set up 3x plus 15 equals 3 minus 3x. Now we're just going to solve this for x. Go ahead and add your 3x to each side. So we've got 6x plus 15 equals 3. Let's get rid of that 15 here. So we've got 6 times some number is going to equal negative 12. In which case we know that 6 times negative 2 is going to give us negative 12, so x has to equal negative 2. Now we're not finished. That's only half of a point. We're trying to figure out where they're going to intersect, so we need the y-coordinate too. Let's take that negative 2 and substitute it in for x in one of the equations. So I'm going to say y is going to equal 3 times negative 2 plus 15. 3 times negative 2 is negative 6. So negative 6 plus 15 is going to give us 9. So our point that we're looking at is the point negative 2, 9. To check it, you could plug it into this one. See if it works. So this is like our little check here. We're going to say 9 is going to equal 3 minus 3 times negative 2. 3 times negative 2, it's going to be negative 6, but when you subtract a negative 6, it's like plus. So 3 plus 6 equals 9. So we have 9 equals 9. Pretty easy. Let's look at B. Y equals x squared minus 3x minus 8, and y equals 2. This one's going to follow the same set of rules here, the same procedure. If we know that both of these things equal y, then they have to equal each other too. So x squared minus 3x minus 8 equals 2. Let's subtract 2 from each side. And we now have x squared minus 3x minus 10 is going to equal 0. Now you can use your quadratic formula, or you can factor. It's up to you, whichever way you want to do it. If you use your quadratic formula, a is 1, b is negative 3, and c is negative 10. I'm going to go ahead and factor. I'm going to factor the box and diamond way because I know that there's some people who are struggling with factoring, so I'm going to go ahead and hopefully give you a little refresher on how to do it this way if you don't remember. If you can do it without this, that's even better. So remember, when factoring using the generic rectangle, you're going to put your first term down here. We've got x squared. That's the area of this piece. We know the area of this piece here is negative 10. That comes from multiplying this part and this part. When we multiply those together, we get negative 10x squared. We put the product up here. Beneath, down here, we need to put our middle term, which is negative 3x. So we're looking for two numbers that multiply to give us negative 10x squared and add to have a sum of negative 3x. Well, factors of 10 are 5 and 2. If we have a negative 5x and a positive 2x, that should work out. And then we're going to put these into our generic rectangle. So we have negative 5x we have positive 2x. Now we're going to look for the greatest common factor here. We know that the dimensions here are x, and this dimension is also x. Then they have to share a factor there, and that factor is x. X times blank is x squared. Well, that's got to be an x. X times blank is negative 5x. That's negative 5. And then x times something here would give us 2x. Well, that's got to be 2. So what we're looking at right now, I'm going to take this, I'm going to move it, we're going to sneak down here beneath us, or beneath this part. We have x plus 2 times the quantity of x minus 5 equals 0. This is just a continuation of that equation right there. Now use your zero product property. So I'm going to take it here and I'm going to say x plus 2 has to equal 0. And we know x has to equal negative 2 in that case. And if x minus 5 has to equal 0, we know that x has to equal 5. But remember, you're not finished. You're trying to find points where they're going to cross. Now this graph is going to be a parabola crossing a horizontal line. So here's our axes here. We're going to have this y equals 2. It's going to be, going across here. It's horizontal. And then we're going to have our parabola that's going to extend down and come up here. So when you're thinking about those kinds of things, we're going to have 2 intersection points. So we have to plug each of these in to figure out what y is going to be. Now, if you plug in the second one, that makes it pretty easy because there is no x, which means the y coordinate for both intersection points has to be 2. So we're going to have the points, I'll write them up here, negative 2, 2, and 5, 2. If you want to check them, take your x values, plug them in here, and you should get 2 as your output. For time's sake, I don't want to go real in depth. I'd love to show you the graphing way on the calculator, but you do need to know how to do it algebraically for your tests. So this is problem 1-21. Thanks for watching. If you have questions, make sure you ask somebody soon.